Here in this video, let's look into Ohm's law, explanation, disadvantages, and an example. What is Ohm's law? According to Ohm's law, the current flowing through a conductor is directly proportional to the voltage across the conductor and inversely proportional to its resistance. In other words, if voltage is increased, the current will also increase as long as the resistance remains the same. If resistance is increased, the current will decrease as long as the voltage remains the same. If the resistance is decreased, the current will increase as long as the voltage remains the same. Mathematically, Ohm's law can be expressed as follows. I is equal to V by R, where V is the voltage across the conductor, I is the current passing through it, and R is the resistance of the conductor. Ohm's law can be used to calculate any one of these three variables, voltage, current, or resistance, given the other two. For example, if voltage and resistance of a conductor are known, the current passing through it can be calculated using the formula I is equal to V by R. Ohm's law is a fundamental concept in electrical engineering and is used extensively in design and analysis of electrical circuits. It forms the basis for many important applications, including design of electronic devices, power distribution systems, and electrical safety systems. It also has certain disadvantages. Some of the disadvantages of Ohm's law include limited applicability, temperature dependence, inaccurate prediction, safety concerns, and limited information. Let's look into detail. What is limited applicability? Ohm's law is only applicable to linear circuits where the resistance remains constant. It cannot be used for circuits with nonlinear elements like diodes, transistor, or capacitor. Temperature dependence. The resistance of the conductor is dependent on its temperature. This means that Ohm's law may not hold true if the temperature of the circuit changes. Inaccurate predictions. Ohm's law assumes that the current and voltage are in phase with each other and that the conductor has a uniform cross-sectional area. In reality, this may not always be the case, and the prediction made by using Ohm's law may be inaccurate. Safety concerns. Ohm's law does not take into account the safety hazards associated with high voltages and currents. Limited information. Ohm's law only provides information about the relationship between voltage, current, and resistance. It does not provide information about other important circuit parameters like power, capacitance, and inductance. Let's look into an example. Here the voltage across the circuit is 12 volt and resistance is 600 ohm. So we can calculate the current by the formula I is equal to V by R, that is 12 by 600, which is 0.02 ohm. Thank you.